Now, this is a video that I'm asked to do all the time, and it is when you are building an extension over here and you butt it up against an existing building. This here is trying to represent a standard roof loft area. This could be a bedroom, could be a living room. It depends if it's single story. It doesn't really make any difference. We're going to butt up against here. I'm going to draw that in here now. I'm going to try and show you the relationship between a flat roof, which would be a warm flat roof, when it comes up against here, and how you deal with the ventilation situation here, because obviously this is going to be disappearing, and it's like, okay, what do we do? And what we want to try and do here, we want to try and isolate both areas. I find it quite and obviously I do it, so I understand it, but so many people ask me, how do you do it? I thought I'd do that video. I'll show you quickly here on this drawing, and then we'll go into the office. I'll show you some real live examples. So let me do this for you now. Okay, so now you've seen what I've done here. I just changed a few things around. Now what I've done is that just here I've put a vent in, and of course in between the rafters the vent can then vent in now, and we've still got movement of air. We haven't had to adjust this whatsoever, but of course previously when you looked at this there was venting coming in from underneath the eaves. I've got rid of all of that. Now if you look here at this particular build up here, this is between the joists. You must stop any movement of air from outside here coming in to this area. We've stopped it here. Now between there and there, if you look, I put a little black mark. I'll just put it back in again for you. There it is there. If we come to this side, the reason that black mark was there in the first place was because when we put the loft insulation in, theoretically, we're not supposed to push it right up into the rafters because we don't want to stop the flow of air coming all the way up. That's what that was there originally. But of course, now that is wrong. So that has got to come out just in that area there. And we've got to try and make sure that we join right the way across with our thermal element. Well, now we're not blocking the airflow because it's not coming up. So we can bring that across to here. And what I normally do is, as I'm building this, I will put PIR in this area. But to be honest with you, any kind of insulation is better than nothing. So we are airtight because there's no air going to get down from here or here into this area. Where this comes across into that, to this junction here, up here, we're looking at keeping it totally airtight above at that junction. So whatever you do here, you must make sure that it's airtight. Now I've put a vapor barrier in. You can see the vapor barrier goes, see it going up the insulation across, up this black area here and this black area here above the furring. You can see the furring just in there, right? This black area is ply or OSB. We like to use OSB 3 tongue and grooved. So I've got my OSB 3 tongue and grooved. I've got my air vapor controller again all around my thermal insulation. I've put more OSB 3 over the top with my felt or EPDM. I don't like glass fiber, so I wouldn't use glass fiber. You can use whatever you want, obviously, but I'm just pointing out that's what I've chosen to show you on here. So the fact is that do we need an air vapor control layer at this particular point on this side? We need to make sure it's airtight and no air is coming in from that side there. So that's why at this point here, I foam all this in using PIR insulation, which is inside here, and I foam all this up because theoretically, when you come across here, most houses should have an air vapor control layer going across here, and they shouldn't have lights being pushed through it. This should be airtight with an air vapor control layer at the bottom. They haven't got it. Now, you know, I'm assuming that's an old house and it wouldn't have it. So as long as you bring the thermal insulation past here and you block all of this off so no air movement can come back down from here, yes, you can put, we do not want air movement going that way. We do not want that, okay? We don't want any movement getting in here. So blocking it and foaming it up with PI or insulation is the way to go. Do you actually need an air vapor control layer? Well, it really depends on how close all of this is. Normally, this part here is a little bit further over. That RSJ is a little bit further out, and you don't. You can put one in there if you want to. It's not necessary there. What we're trying to do with the air vapor control layer here is stopping any moisture getting up into what we call our sandwich here. Here, we're going to only transfer moisture through that way without the air vapor control layer. And of course, you've then got the movement of air in here for it to get out. But what you don't want is air blowing through. That's why foaming across that area is okay, and that will work. So that gives you a good idea. And if you look at what we've done here, look, thermal, up here, thermal all the way across, join the thermal. You know, someone once said to me, I think I read it somewhere, if you're doing something like this and you've got to take your pen off of the drawing, so, I mean, I'm going up here, so I'm fine. I know that that thermal insulation is going behind that bit of timber, that's fine. When I get to this point here, I've got no choice. I'm going to have to take my pen off to get to that point. But what's in between me? Just a couple of bits of timber. There's a bit of a furring and a bit of an OSB. Nothing I can do about that. So my thermal insulation has been done the best I can. I moved my pen all the way along. My thermal insulation has been done the best I can. I get to this point. Until I go past this bit of timber, that's only 18mm ply, more thermal insulation. So yes, I have had to take my pen off the drawing just there. Yes, I've taken it off there. But apart from that, those two small things, I've got a continual thermal envelope going all the way across, up, across there, and across there. Great. Okay. Air vapor control layer. Continuous. And that is the area where I'm concentrating on, where I need my air vapor control layer. It's just because it extends past this particular point just here. I don't know why my pen's not working, but just because it extends past there, that's only because we don't want all this stepping down. Now, that said, we've done a few jobs recently that people don't want such a big fat area just there. So what we've actually done, because of the way you'd be standing in a garden or something here, and your eyesight looks across an angle like that, we've actually brought the warm roof across, and then we've gone down at an angle like that and then put the guttering down there. It's really surprising the things that you can get away with, which means that when you're out here and you're looking at it, you don't see this massive, great big fascia, which is something that people bring up all the time, right? Because they don't like it. Right, so that's that dealt with. Vent just there, in there, you've got, that is a continuous vent, a full length. That will be very similar to a vent that goes here, which is a soffit vent. Soffit vents are the way to go because they offer so much ventilation. So you've got a soffit vent there, is what the BS standard wants. That's what you're going to get there. That's what you're going to get there. And that's what you're going to get up there if you put that down. Now, here's an interesting one, right? I've put up here a vented ridge. You won't believe the amount of times that I see vented ridges done incorrectly. And I'm going to be doing a video very shortly on this because you can't even buy vented ridges. Most people buying vented ridges are being sold vented ridges, but they're not actually getting vented ridges. They fit them as vented ridges. Not only that, they put the underfill. Oh, anyhow, that's another video. Okay, so that I'll go into that video another time. So now let's go into the office and I'll show you some real examples of exactly what I've done here. So I've got the camera here in front of me and it's a bit wiggly woggly because I've got to try and get into the roof, but you can see obviously the loft inside. It's an old loft area inside. So I'll run this and we'll just see it go in, and I'll stop it as we move in. So there we go. So now we're moving inside. So you can see that I've blocked it all off, foamed it all off now. So that is the back of the roof. This is the OSB going up, which I showed you on the other drawing there. And as you can see, it's completely and utterly sealed off. And if we look here, the loft insulation has been pulled back so that we can do this work. So now the loft insulation needs to go back across this area. And the interesting thing is that I told you before, I mean, you can just about see a light fitting coming through just there. Let's go back a little bit there and just see that light fitting. You can just see the corner of it just sticking through. And the interesting thing is that, you know, there's no air vapor control layer in this area anyhow, and that's why I was saying to you about this point, it doesn't really make any difference about the air vapor control layer and this junction, because theoretically there's going to be a vent higher up here which is not on here. Unfortunately, it's very difficult to take pictures of that vent, and any moisture that came up from the roof down below is not going to be a problem, because it's going to get out of this area. Let's go and have a look at another bit. So this is what it looks like from the outside, and if I just, you'll see there's plenty of room underneath here for the air to get right up underneath there to the vent, which is underneath there, which is allowing the air to in. Now that gives you an idea of what it looks like when it's finished. Now here's that one I was talking about with the lights. Actually, you can see more of what's going on here. So the vent's going to go in at the top just there. All of this, you've got to take that we've been getting into the loft over the top of this, and you think about, you could put your foot through. There's a lot of damage that you could do inside a loft here. It's a bit precarious the way it works, but you know, it does work. Anyhow, we're in there, we've done it, insulated, foamed in. Look at the amount of work that it takes to do this properly. This is why most people don't do it. This is why it's missed. But if you miss this, your warm roof doesn't work properly, and you've got all sorts of different scenarios. Can you imagine the drafts that could be going down into the from here? You've got drafts going all the way down. I mean, obviously, look, you know, we need to fill these up. I'm pretty sure we went along and filled those up again afterwards. But you know, you look at the amount of work involved in doing this properly. So look at this, just one of my men cutting in. The amount of time it takes to do this properly. No wonder a lot of people miss it. Now, don't forget, I'm going to put a link up here as soon as I've done the video. It should be in about a week's time, to do with this vented ridge, because that's a big problem I see all the time. In the meantime, just get back to me if you need any more information. Don't forget to subscribe, and don't forget to give me the thumbs up. Speak soon.